I would like to welcome you to another Imaging Sciences Treatment Studio tutorial. This video will provide instructions for implant planning and placement using Treatment Studio. Our objective is to cover the basic tools and functions of Treatment Studio, including implant planning as well as the implant planning specific features for virtual placement of implants within a 3D volumetric data set. Included among this tutorial's topics are proper scanner settings for implants, tracing the inferior alveolar nerve, placing an implant in the 3D view and using cross-sectional views for placement adjustments, capturing images to the gallery, saving treatment planning as in vivo, single-file DICOM or multi-file DICOM files, and learning how to make a presentation video of your treatment plan. Before we begin planning and placing implants, we must have a good CBCT scan of the desired anatomy. In most cases, a scan taken with a 0.3 mm voxel setting for 8.9 seconds will be adequate, giving you a good view of the bone and the inferior alveolar nerve. If implants are to be placed in only one arch, it is recommended that the scan be collimated to reduce patient exposure and the incidence of surface artifacts. Let's take a look at the scout view of a mandibular implant case. While the collimator shutters have been lowered to the lower arch, reducing the image field to 6 centimeters, the crowns of the maxillary teeth are in the exposure field. Any restorative work done in the maxilla, when scanned, may produce scatter artifacts that are caused when X-ray photons are diffracted from their original path when coming in contact with very dense objects. This could reduce the image quality in the area of interest. To avoid this, you should raise the patient's head by raising the chin cup to reduce maxillary exposure. You could also use cotton rolls to separate the occlusal surfaces to further raise the maxilla. Of course, you may still have the presence of scatter caused by restorative work in the lower arch. If you're doing a rescan on a patient to verify the position of a placed implant or to later check the status of a bone augmentation, you may find that our 4.8 second 0.3 mm voxel QuickScan or QuickScan Plus collimated scans are sufficient. You will further limit radiation exposure to the patient as well as decrease the opportunity for motion artifacts caused by patient movement. In some instances, you may need a higher resolution scan at, say, 0.25 millimeters or 0.2 millimeter voxels. We strongly recommend that you collimate these scans to the arch of interest. They will take 26.9 seconds rather than the aforementioned 8.9 or 4.8 second scans, which means that the patient will be exposed to more radiation and it will increase the opportunity for patient movement. However, you will see differences in the detail of bone structure of the teeth and the jaws that you are scanning. This is especially useful if you have an edentulous patient whose bone is resorbed and you don't see a lot of trabeculation of the bone. Higher resolution scans are also useful in viewing the interior portion of the maxilla, where the cortical bone itself tends to be very thin. The higher resolution settings may help visualize the outer edges of the bone, especially if the cortical bone covering the anterior teeth is less than 0.5 millimeters thick. A higher resolution scan may also be useful in identifying the inferior alveolar nerve when the surrounding cortical border of the canal is either very thin or perhaps non-existent. The higher resolution scan will help identify a lack of trabeculation, which will help identify the canal. Again, a longer scan time will increase the chances of patient movement, which will lessen image quality. While we recommend that the patient be situated in a chin cup, with the possible exceptions of an orthodontic tracing or oral maxillofacial surgical case, and secured with a Velcro headband for all scan types, it is even more important as we increase scan times to reduce patient movement. Let's begin by identifying and tracing the inferior alveolar nerve. When a case is loaded, Treatment Studio will open in the Arch Section tab. First, let's change the screen layout. To do this, click on either Change Layout in the Control Panel or the Layout icon on the toolbar. They do the same thing. Select the top left view. If the mandible is not fully viewable in the panoramic view window, select Adjust Range and Orientation in the View Control window, then left mouse click on a green horizontal line in the panoramic view, and while keeping it depressed, move the mouse to include the desired anatomy. It may be necessary to move both lines. Deselect Adjust Range and Orientation when finished. Select Slice just below Panoramic Image in the View Control window. Now let's adjust the views for better visualization. To adjust the size of the image, place the mouse pointer in a window, hold down the Control key on the keyboard while holding down the left mouse button, and move the mouse. To pan an image, place the mouse pointer in a window, hold down the Shift key on the keyboard while holding down the left mouse button, and move the mouse. Adjust the brightness, contrast, and image sharpening as necessary in the View Control window to better view the nerve canal. If the full length of the nerve canal is not seen in the panoramic view, do the following. Move the horizontal orange line on the panoramic to just below the CEJ of the lower central incisors. Select Create Arch Spline, which is the second icon from the left on the toolbar, by left mouse clicking on the icon twice. You'll be asked, do you want to create a new spline for focal trough? Click New. In the axial view, start placing points in the arch by left mouse clicking every ½ inch to 3/4 of an inch or so. Begin just posterior of the mandible on either side and continuing through the middle of the arch until you go past posterior on the opposite side of where you started. Left mouse click to set the final point, then right mouse click to create the new spline. You may only do one side of the arch if you desire. Place the mouse pointer on top of a red outlined yellow dot which resides in the general area where the nerve canal is not clearly seen. While holding down the left mouse button, move the dot either buccally or lingually until you see that section of the canal clearly in the panoramic view. Repeat as necessary until you see the full length of the canal in the panoramic view. Note, you may use your mouse wheel when the mouse cursor is on the pano as well to make adjustments. Once the canal is clearly defined, place the mouse pointer on the vertical line in the panoramic view, and while holding down the left mouse button, drag the line until you see the inferior nerve exit at the mental foramen in one of the cross sections. We are now ready to create a nerve pathway using the automatic tracing method. In the control panel, select Pick Seed Points. Place at least 2 points within the canal in the panoramic view, one at the most posterior aspect of the canal and another where the nerve canal exits at the mental foramen in one of the cross sections. For some cases, 3 or 4 points may be more reliable. Press Finish in the control panel to end. The canal is now marked following the less dense pathway. If necessary, you may mark the anterior loop by selecting Pick Seed Points again and placing a point at the green vertical line on the pano and another at the end of the canal. Press Finish. The automatic nerve feature will not be available if the volume has been reoriented. If the volume has been reoriented, reset to the original volume orientation by first selecting the Volume Renderer tab, then selecting Patient Orientation on the toolbar. Next, select Reset to Image Coordinate System. The automatic nerve feature will now be available for use. For additional information about nerve tracing, including tracing a nerve manually, please view the Tracing the Inferior Alveolar Nerve using Treatment Studio tutorial that is posted on YouTube. Any nerve that is traced in a way that does not conform to the actual pathway of the nerve can lead to surgical complications if diagnosis, treatment plans, or actual treatment is based off of incorrect tracing. It is critical for the end user to learn how to properly perform nerve tracings correctly. If you notice any inconsistencies or software problem with nerve tracing, or have further questions or concerns about nerve tracing, please contact Imaging Sciences Technical Support at 800-205-3570 or email us at isicust techsupport@imigingsciences.com. Before we place implants, let's take a look at some of the tools and settings in the Implant tab. By selecting Preferences, which is represented by the gear icon on the toolbar, we will open a customization window so that different rendering, color, and visibility preferences can be set. The Tooth ID System section will allow us to set the numbering system as either universal or international. Clipping preference enables you to include any of the available objects that you want to clip within the 3D volume or a model. Let's not select anything just yet. Let's click OK. To see what happens when no objects are selected in the clipping preference, let's make the nerve visible by clicking Nerve in the Visibility section of the control panel. Next, let's quickly place an implant. Let's rotate the head by selecting the Right View Positional icon on the toolbar for a better view of the implant site. I will left mouse click, and while holding the button down, I will move the mouse to fine-tune the position. Next, select Add Single Implant and then choose implant number 29. Move the mouse to the area in the 3D view to where you wish to place your implant and left mouse click. After placing the implant, use the 2D axial section to locate it to the crest of the bone. I will thoroughly cover this later during this tutorial. We'll select Enable Clipping in the Clipping section of the control panel and select Sagittal. Let's crop the image to the desired area by moving the slider bar or by placing the mouse cursor in the rendering window and moving the scroll wheel. You will see neither the implant nor the nerve canal is clipped as the clipping plane moves past the objects. Now let's go back to Preference and select Implant and Nerve, then click OK. Now when clipping, the volume objects selected in the Preference control panel are clipped as well. Let's remove the implant for now by left mouse clicking it and pushing Delete on the keyboard. Let's turn off clipping by deselecting it in the control panel. Next, we'll click the Front View Repositional icon to reorient the head. Next, click the gear in the toolbar to reopen Preferences. Next, let's enable Show Collision Warnings. With this checked, you will be alerted to an implant placed within 2 millimeters of the traced nerve or an adjacent implant. This allowance may be changed as desired. You may choose which rendering method is to be used in the Implant tab. Default will use the rendering settings selected in the Volume Renderer section of the Preference control window, which is opened by clicking File on the menu bar. Choose Preference and then select the Volume Renderer tab. Click on the Init or Initial Rendering drop-down and you can set the rendering quality default, which will be used upon opening Treatment Studio. Let's close Preferences and reopen Implant View Preferences. We'll select Enable Collision Warnings. Next, click the Rendering Method drop-down. Performance will lower the quality of the image to increase the frame rate. Quality will improve the rendering but will decrease the frame rate. Any limitations in your computer's processor or RAM may dictate that performance be used. In the color control, you may set various colors for abutments, restorations, and collisions. Detail implant settings will allow you to adjust the default settings for individual implants. As example, let's change the generic default of implant number 29. We'll select a Camlog screw line 4.3 millimeters by 13 millimeters as the preferred implant. Now when we add a new implant for tooth number 29, this change will be reflected. You can always change to a different implant in the control panel on a case-by-case basis without changing the default implant setting. Now let's select Preferred Implant Settings. This selection will allow us to edit the implant library that shows up in the control panel. To delete an implant, highlight it in the Preferred Manufacturer and Product window and click on the left arrow. To add implants to the Preferred Manufacturer and Product list, select a manufacturer in the Select Manufacturer window, then select the product, and then lastly click the right arrow to add the implant to the preferred list. Select OK to save any changes. Any change you make in implant view preferences will be the new default setting as you open subsequent cases. Now we are ready to place an implant. For better visualization of the implant site, you may want to clip the volume. Select Enable Clipping and click Flip and Sagittal if they're not already selected. Move the slider control until only the desired anatomy is seen. Now let's select the right view positional icon on the toolbar to move our volume into a position where we can better visualize the implant site. We may want to left mouse click on the image and rotate it slightly by moving our mouse. If the nerve has been traced, ensure that Nerve is selected in the Visibility section. To more accurately visualize the bone boundary, you may want to use the Image Enhancement tools in the View Control section of the control panel. You may adjust the brightness and contrast levels and change the sharpen filters to either No Sharpen, Mild Sharpen, or Hard Sharpen. For single implants, it is easiest to use the Add Single Implant function in the control panel or Insert Implant on the toolbar. If you are doing multiple implants, it is better to select Pano Implant in the Planning Layout section of the control panel. We will get to this screen in a little while as we place additional implants. Let's select 3D Implant in the Planning Layout section. Left mouse click the Add Single Implant button. The Select Implant window will appear where we will click on tooth number 29 or tooth number 45 if we're using the international setting. Click OK. We now have an implant tethered to the mouse cursor. Move the implant to the desired location on the volume and left mouse click to place the implant. Accept the default implant properties in the implant section of the control panel, or you may make changes in the manufacturer, product, diameter, or length drop-down menus. Once placed, adjustments to the implant can be made in the 3D rendering window. Before we begin making adjustments, activate Long Axis in the Visibility section of the control panel. The long axis displays a colored rod running through the long axis of the implant in the 3D volume renderer window. This tool will aid in aligning the implant with the opposing occlusion. You may use the widget to adjust the mesial-distal spacing, the lateral position, and the buccal lingual position when looking at the implant coronally. By clicking on and moving the blue arrow, you may change the mesial-distal distance or the green arrow to change the vertical position. You may left mouse click on any of the 8 orange wedges located on the rotation circle, and while holding down the button, move the mouse to change the mesial-distal or the buccal lingual tilt when looking at the implant coronally. Select the distance measurement icon on the toolbar to measure from implant to tooth. Rather than using the 3D widget, most find it more accurate and easier to make these adjustments in the 2D cross-section view windows. Let's use the axial cross-section to begin our adjustments of the placed implant. Click and drag the implant to the crest of the bone. The AB line in the sagittal window determines which axial slice is shown in the axial window. Let's move the AB line so that it is at the crest of the bone. Now use the distance measurement tool on the toolbar to measure the distance between the implant and the adjacent tooth in the axial view. Once distance measurement is selected, left mouse click to begin the measurement and left mouse click at the end. To delete the measurement, left mouse click on it and push delete on the keyboard. After the implant has been positioned in the axial view, rotate the axial AB line until it is perpendicular to the arch. This AB line gives us the plane for the cross-section shown in the sagittal rendering window. Having the axial AB line perpendicular to the arch gives us the most accurate view of the amount of bone available for implant placement. Now you may left mouse click on the implant in the sagittal view window, and while holding down the button, move the mouse to change the buccal, lingual, or vertical placement. You may also make changes by manipulating the 2D implant widget that appeared when the implant was clicked. The widget is designed to minimize visibility in the slice renderer, but still provide a high level of versatility in implant positioning as well as sizing. The rotation circle has 8 orange handles for implant rotation along the same plane as the currently displayed slice. Selecting any one of these handles by left mouse clicking and moving your mouse will tilt the implant buccally or lingually. Either of the two red handles, circles, can be selected and dragged towards or away from the implant to reduce or expand the diameter of the implant sequentially through any available options for that implant model. Either of the two blue handles, circles, can be selected and dragged towards or away from the implant to reduce or expand the length of the implant sequentially through any available options for that implant model. Once you're satisfied with implant placement, use the distance measurement tool on the toolbar to check distances. If possible, you would generally want to place the implant at least 2 millimeters from an adjacent natural tooth and allow 3 millimeters from an adjacent implant. Additionally, it is generally recommended to allow at least 2+ millimeter distance from the implant to the buccal plate and 2 millimeters from the implant to the palatal plate. Any placement or positional changes made in this screen can be modified in the 3D implant screen. When finished with measurements, you may left mouse click on text measurement and push delete on the keyboard. It is recommended to place the implant more to the palatal side because of the possibility of tattooing or graying of the soft tissue due to the implant, which is unaesthetic. Additionally, the cortical bone on the palatal side is stronger than the facial side. The bottom 2D rendering window uses a color gradient reflecting an approximation of the density of the bone surrounding the implant. These HU or Hounsfield unit value approximations may not be as accurate if your CT hardware calibration is off. Once density values are checked, you may turn off the density visibility in the visibility section of the control panel. When turned off, you will see an additional cross-section. This additional cross-section shows you the mesiodistal relationship of the implant to the adjacent teeth. Here you can also click and drag the implant or use the widget to adjust the mesiodistal angulation as well. To aid in more precise placement, you may want to turn on the toggle grid located on the toolbar. The distance between each grid line is 5 millimeters. The grid lines will tell us if our implant is parallel to adjacent structures. This is very helpful when placing interior implants where the teeth are very close together and the tooth becomes more narrow towards the root tip. When the toggle grid is turned on, there will be a vertical grid line passing through the central axis of the implant. This will be very helpful in showing us the relationship between the implant and the opposing occlusion. If the implant is properly placed, it may be easier to place restorations using straightforward abutments rather than the angled ones. A common problem encountered during treatment planning is not being able to see structures like the inferior alveolar nerve or recently placed restorations. This problem is quickly fixed by going to the visibility section and checking the items you wish to see in the rendering window. Conversely, you may uncheck items that you do not want to see. Keep in mind that items such as sleeves, wax-ups, and maxillary and mandibular models will not be available unless you have received and loaded a surgical guide case. Any unavailable items will be grayed out. As example, let's select Profile Only in the Visibility section. This tool will allow you to see only the outline of the implant in the 2D cross-sectional view windows. This could be very useful for detecting if the implant is going through a bone defect. Let's go ahead and place 2 more implants. Rather than using Add Single Implant, it is easier when placing multiple implants to choose Pano Implant in the Planning Layout section of the control panel. When in the Pano Implant window, begin by making sure that the focal trough conforms to the shape of the jaw. If it is set properly, the implants will be dropped somewhere between the inner and outer lines of the trough. You may adjust the focal trough by clicking on any red circle on the middle trough line, and while holding it down, move the mouse buccally or lingually. I wouldn't worry too much about this right now, however, as you can easily make your adjustments in the 2D sectional windows. Next, left mouse click on the desired implants and drag them to the general area of placement in the pano. You may then click on an implant for the widget tool to appear, which can be used to make some basic adjustments to the implant. Any placement or positional changes made in this screen can be modified in the 3D implant screen. You may also select the distance measurement tool and measure spacing. However, for more accurate placement, you will want to make your final adjustments in the 2D sectional view windows. When finished placing implants, click 3D Implant in Planning Layout. In the Visibility section, activate Angles. The Angle option controls the visibility of the angle between the long axis of adjacent implants as well as the angles of the abutment for each implant. I will enlarge the 3D volume so that you may better see the changes of angulation between the implants as I rotate their mesiodistal aspect by clicking and dragging one of the 8 rotational handles on the 3D widget. Another helpful visibility option is Trajectory. Trajectory displays the simulated path of the implant during surgical placement. If you wish all implants to remain parallel to one another, click Add Single Implant and choose to make all mandibular implants parallel. Click OK. If you only want to have some implants parallel, place the implants to be parallel first, then deselect the All Mandibular Implants Parallel option, then place additional implants that are not to be parallel. The ones placed earlier as parallel will remain parallel. Generally, it is best to have implants parallel to one another when case planning for a bridge or for the anterior implants of an All-on-4 because they provide more stability. As you are positioning your implants, you may see collision warnings that will alert you if you're too close to adjacent implants or the trace nerve. We established the collision tolerance earlier when we were in the implant view preferences. Generally, it is good to have the tolerance set at least 2 millimeters so you will always be alerted if you're getting too close to the nerve or to an adjacent implant. Let's go ahead and position our 2 additional implants in the 2D views as we did earlier. Let's turn on the density option in the visibility section of the control panel. This option will give us a rough idea as to the density of the bone surrounding an implant. In the 3D volume, let's click the implant for tooth number 30 so that it will become visible in the 2D cross section. Let's move the sagittal AB line to the crest of the bone. Next, position the implant in the crest of the bone as we did when placing implant number 29. The implants that are not currently active are represented by a blue ring. Let's activate the distance measurement tool and measure the distance from 29 to 30. It's a little short of the generally recommended minimum of 3 millimeters, so we'll move it posteriorly a bit. We will click on the end point of the measurement line and drag it to the implant to remeasure. I'll say that's good for demonstration purposes, so I'll click the measurement and push Delete. Now let's click number 31 in the 3D volume to activate it. Let's check our distance between numbers 30 and 31. If you would like to change any of the implant characteristics, go to the Implant section of the control panel and select from the drop-down menus. I'm going to change the implant length and the width. Remember, this can be done from the 2D widget's blue or red handles as well. Let's rotate the axial AB line until it's perpendicular to the arch. Now we can click on the implant in the sagittal view and fine-tune our placement. Let's deselect density in the visibility section to open the lateral view window. As we did previously, click the implant in the 3D volume window that you want to reposition in the lateral view. After the implants have been placed, you may find that the treatment lock option on the toolbar is helpful. When treatment lock is on, you will not be able to add more implants or make changes to existing implants. This is helpful when you want to navigate in the rendering window without the risk of accidentally modifying your plan. To create an image of the rendering window, select View on the toolbar and then select Capture to Gallery. You will be given a choice of what to save. Let's accept the default whole view and select OK. You will then be given a choice to make changes to the name or to remove or add comments. Let's select OK to accept the defaults. When the gallery is opened, you may crop the image. To open the gallery, click on the Gallery tab on the toolbar. Let's select the last image in the Images section, which will be the one we just added. Next, select Crop Current. Drag the outside lines inward to clip the image. When finished, right mouse click. Choose to either replace the original image with the cropped image, or you may keep them both. Select an image and click Export. You may select All to export all images. In the Image Format drop-down, you may save your exported image or images as JPEGs, bitmaps, PNGs, TIFFs, or as DICOM files. Click OK. You may also attach a gallery image to your Outlook Mail as a JPEG. You may use Mozilla Thunderbird email client as well. Email programs like Hotmail or Gmail will not work with the Treatment Studio email function. You will have to export the image from Gallery, then open your email client and attach the image. For additional information regarding the Gallery tab, please consult your Treatment Studio User's Manual or view the Treatment Studio Image Export tutorial on YouTube. If you would like to create a presentation video of your treatment plan, select Generate View Sequencer on the toolbar. In the Animate section of the View Sequencer, let's deselect all but implants, except clipping, which will set the sequence to include the preset clipping actions. The sequencer has both axial and buccal camera orientations and zoom levels. Let's accept the defaults. If you would like to vary the speed of the playback, choose from the drop-down menu. Frames per second may be adjusted upward for smoother scene transitions, and you may loop the video for it to run continuously. Let's go ahead and watch our sequence video of the implants we have just placed. Let's save the sequence as an AVI movie by selecting Video Capture. We'll keep the defaults. For fun, let's add an ending logo to the movie. Select Add Logo, then browse for the JPEG image you would like to use. If you only have a bitmap image, you can convert it by using Microsoft Paint. You may change the background color of the logo if desired. Select Capture. Once recorded and saved as an AVI file in the selected folder, let's play the movie. Treatment Studio gives you the ability to create movies of view sequences in the Volume Renderer tab as well. I have seen these movies used very effectively when presenting a treatment plan to a patient. When you're finished treatment planning, you must save your work, otherwise it will be lost when the case is closed. There are several ways of doing this. First, select File on the menu bar. Next, select Save As. You may then select to save the case as an in vivo, a single file DICOM, or a multi-file DICOM file. You can then accept the default folder and file name or change either before you save. Accept the default full and click Save. Or you may save your treatment plan by selecting Save as Project. First, select where you want to save to and then accept or change the default file name. Saving your case as a project will save only the changes you made to the original scan. When you reopen the case project file, the scan will load with the changes made. The file size is smaller than saving it as an NVivo or DICOM file, and it will open faster. If you're saving the case to a laptop that travels out of the practice, choose the Save As option if the original DICOM or NVivo file you opened is located somewhere on the network. This concludes the Imaging Sciences Implant Planning and Placement tutorial. For additional information, recommendations, or assistance, please contact Imaging Sciences Technical Support at 800-205-3570 or by emailing isicusttechsupport@imigingsciences.com. From all of us at ICAT, thank you.